Okay, this is going to be the last video of the implicit series, and this is on finding the second derivative. Um, this may be the final boss of implicit differentiation. So if you're here, you're doing pretty good. You're doing very well. You're doing very well. Good job, guys. You're doing great. This is not easy. Okay, so I skipped this way back when in the first video. I'm kind of going to come back to them now because this is finding the second derivative. To find the second derivative, um, first, before I even do that, let's talk about what is second derivative. You've seen this before. We are familiar with like y prime. That's the first derivative, right? And then you're familiar with like y double prime, right? That's the second. And in our notation, the new notation, right? dy dx, that is also the first derivative. And y double prime we call d squared y dx squared. You know, like, okay, why is that there? The reason that's there is that when we think about y and you're taking the derivative of y, if you take the derivative of y one time, d dx of y, you get dy dx. If you do it twice, you get d dx dx times the y, which is d squared dx squared times y, which is why we have d squared y dx squared. Okay, so that's the notation, just in case you're wondering. So here, we need the second derivative. I'm picking up on this problem that we did earlier just to make it a little bit not so bad. So we're going to carry on straight from here. I'm going to take the second derivative of this. So we're going to do, I'll keep it in purple. No, I'll make it red. Make it, let's go crazy and make it orange. You know, I'm unhinged right now, guys. I'm unhinged. Here we go. D squared y over dx. There we go. Wow, that pops. I'm taking the second derivative. Now, to take the second derivative, you may have noticed on the right here, we got a quotient. We have a quotient. And when you see quotient, guess what? You got to do some quotient rule here. All right, let's do it. So because this is quite an intense quotient rule, I'm going to take a lot of time to sort of label it and everything. So remember, we have f over g, and it's going to be g f prime minus, so again, low d high minus high d low over low squared. So let's do it. It's going to be my g will be, my low will be, let me center this a little bit here. Well, let's do it like this. My low will be, again, my g will be 3y squared minus x. My high will be f equals y plus 2x, and then we will differentiate. So g prime will be 6y dy dx minus 1. My f prime will equal dy dx plus 2. Okay? So then we're going to use these for product rule, right? Low d high, so it's going to be 3y squared minus x times dy dx plus 2, right? I'm actually going to really run out of space here. Minus, more paper, because I want this all in one clean kind of spot. Minus high d low, so minus y plus 2x times 6y dy dx minus 1. Center this a little bit. I'm like, to actually move the camera to even fit this in. Apologies. Okay, there we go. Center this a little bit. Sorry about that, guys. There we go. Okay. Okay, there we are. Dy dx minus 1 all over, right, this is the product rule, all this is double sheet of paper, all over low squared. My low, it's 3y squared minus x, so it's 3y squared minus x squared. And so at this point, I actually have to literally move the camera up so I can keep going here. You might be thinking, we're done. You might think that. And you know, I wouldn't blame you for thinking that. That seems pretty reasonable to me. I'm gonna try to focus this here. Sorry, guys. Let's focus this. There we go. You know, you think we're done. We're not done though. Crazy, huh? Yeah, we're not done. So in the delta, I believe what it will have you do here is a series of things. It will have you find a value of this derivative. And what you will do is you will go back to your original derivative and you will plug in your value into this. And then that value gets replaced here and here. And then in the other x's and y's, you put your other values and then you evaluate the whole thing. Okay? So I'm going to make up a point that I hope is going to work out. I assume will work out. And we will just do 1 comma 1. So I will evaluate the second derivative at 1 comma 1. So here's what I'm going to do. I'm going to go back to the original derivative. I'm back to the original right here. And I'm going to plug in a 1 and a 1. So back to the original derivative with a 1 and a 1, that's going to be 1 plus 2 times 1 over 3, 1 squared minus 1. And that's going to be 3 over 2, right? 1 plus 2 is 3. 3 minus 1 is 2. Okay, so my derivative at 1 over 1, at 1 comma 1 is 3 over 2. I take that 3 over 2, and that is we're going back to this 2-page equation. There it is. And every dy dx, see all those dy dx's, they're going to be replaced with a 3 over 2. At the same time, all the y's and x's are going to be also replaced with a 1 and a 1. Got it? So the x's become 1s, the y's become 1s, and the ddx becomes this 3 over 2. So let's just rewrite that. We're going to get, right here below, 3 times 1 squared minus 1 times 3 over 2 plus 2 minus 1 plus 2 times 1 times 6 times 1, 3 over 2 minus 1 all over 3 minus 1 squared. Okay? And then you would evaluate this, right, with a calculator. So let's simplify this a little bit more, moving this up a bit. This is going to be just 2, right? So we got 2 here. 3 halves plus 2 is 7 halves. So 2 times 7 halves. Actually, I may not need to use a calculator here. Minus 3 times 18 over 2 is 9. 9 minus 1 is 8. All over 4. 2 times 7 over 2, that is just 7. Minus 24. And then over 4. So 7 minus 24 Well, I'm not going to mess up at this stage. I'm going to use a calculator. 7 minus 24 is negative 17 over 4. So, final answer, d, the second derivative, at, I think the notation they use is usually something like this, at 1 over 1 equals negative 17 over 4. Okay, that would be your final answer. So, just to recap from the very, very beginning, because this was something. You first you take the derivative, and put the normal first derivative implicitly. So these are like, that's why it's advanced, because you got to be good at that. Then you do it again, and oftentimes that's going to mean a quotient rule. You set your quotient up rule nicely, right? You make sure you set your f's and g's right, make it all super neat, put it all in correctly. Set up the product rule, low d high minus high d low. Then once you kind of have like your basic one done, you are going to go back to that dy dx that you found. You're going to plug in the coordinates into that derivative. You're going to get this new value. So this is, right, derivative dy dx at 1 comma 1. That 3 over 2 then replaces all the dy dx's become 3 over 2. That's why these two become 3 over 2. All the other x's and y's get replaced with your coordinates, which in my case were 1 and 1. So all the x's and y's become 1 and 1. Then you evaluate that, and that is your answer. And that is the final boss. That is the final boss of implicit differentiation. You guys got this. Take your time. Take your time. Don't rush it. One step at a time. Okay? Be careful. We got this. Trust the process, guys. You're nearly there. You're nearly there. Okay? Good job.